In this video, we're going to be looking at linear relationships where we have both a multiplier and a constant. Or if you want to think of it in terms of the rule, we're going to have two different parts to our rule or two different steps to our rule. So if you look at the first table, you'll notice it's a little bit different than the ones with just a multiplier that we looked at in a previous video. When the input was 0, the output was always 0 when you had just a multiplier. But this time it's a 7. So what would that tell us about the rule? Well, if my input is 0, 0 times any number is 0. So I'm going to be having to use addition here. What do I have to add to 0 to get 7? Well, I have to add 7. So 7 is called the constant. It's the number that you need to add on. So it's this part of the rule, and it's called the constant. What about the multiplier? Well, the multiplier is not going to be found with an input of 0 because any number times 0 is 0. So let's now look at an input of 1 and an output of 9. What number do we have to multiply by 1 and then add 7 to get 9? Well, hopefully you can see it would be a 2. 1 times 2 would be 2. 2 plus 7 would be 9. So let's try 2 for the multiplier. So there's the two parts to my rule. Let's try it out on the other values that are given. So when the input is 2, 2 times 2 plus 7 is 4 plus 7, which is 11. So that point works as well. And if we have an input of 4 and we multiply it by 2 and we add 7, 8 plus 7 is 15. So it works for that one also. So our rule has been checked. The multiplier is 2 and the constant is 7. Let's see if we can write a rule for the second table. Pause the video and try it yourself first. Okay, this one's a little bit harder because we don't give you, for an input of 0 and 1, what the output is, and those pieces of information are really important. So we're going to try and just guess a multiplier first. What number can I multiply by the input of 3 to get something close to 16? I'm thinking about 5. So 3 times 5 is 15. So let's try and put 5 in here as the multiplier. What would I have to add to 15 to get 16? Well, I'd have to add a 1. So that's going to be my constant. And let's make sure it works for all the other inputs and outputs as well. 5 times 5 is 25, plus 1 is 26. 11 times 5 is 55, plus 1 is 56. So the rule works for those three sets of inputs and outputs. Remember that for when the input is 0, 0 times 5 would just be 0. So the output is just 1, just the constant. So that's a really important input. Input 0 gives us an output that is the constant. And if you put 1 in, 1 times 5 is 5, plus 1 would be 6, and 10 is the input, times 5 would be 50, plus 1 would be 51 for the output. Let's move on to a picture. So remember that when we look at these rules, at position 0, there now should be something there, some number of tiles there. So we're going to have to figure out and draw that position in a moment. But let's look at position 1. You'll notice that it has these 2 blue lightning bolts. Position 3 still has 2 blue lightning bolts. And position 1 has 2 blue lightning bolts, position 2 has 2 blue lightning bolts, and position 3 has 2 blue lightning bolts. This does not change. It always stays what we say is a constant. Constant means doesn't change. So 2 is our constant. So we have two different colors of tiles now. We have different types of tiles. We have happy faces and we have lightning bolts, and lightning bolts are called the constant. So when I draw position 0, then I should have 2 blue lightning bolts. So I would have just 2 tiles, and it would look like this. It would just have the constant tiles, just the lightning bolts. Okay, so to find the multiplier, you want to look at the part of the rule that's growing. So ignore the lightning bolts. Look at just the yellow faces. At position 0, hopefully it's not too surprising that there's 0 groups of happy faces. So at position 1, there's 1 group of happy faces. Position 2, there's 2 groups of happy faces. And at position 3, there's 3 groups of happy faces. How many happy faces in each group, or how many happy faces at position 1, is going to tell me what the multiplier is. There's 3 happy faces in each group or column. How many tiles would there be in position 100? So the total tiles, that means all of the happy faces and lightning bolts put together, would be 100, the position number, times 3. So there'd be 100 columns of 3 happy faces, plus you would always have the 2 lightning bolts. 100 times 3 is 300, plus 2 is 302.